En esta presentación,
Right, in this presentation, we're going to speak of science. So I am going to present some results of our research that will be somehow or the other included in the next special report that we're referring to today. We're going to see the impacts of the change in the use of soil on a series of climate change that go over and beyond the average global temperature, which is actually the metering sticks that are used by many scenarios politically internationally.
Pero hay más impactos que eso. Yo trabajo
with climate models, system that have been becoming more sophisticated throughout the year, and then we have their two compartments, there of the atmosphere, and then the descriptions of the interactions between the two. And then we have them there throughout the years. We can incorporate some components, and then we have there, we have terrestrial one, and then the one, and then you have the year 2000. We can incorporate, and then we have there carbons and biochemicals, and then we have recently the climate ones. We can evaluate the impacts and the use of the soil. That one's deforestation, reforestation. And then we have there, basically there, the ground cells, where you have this array of phenomena of interactions between the different ocean compartments, terrestrial components, biosphere, cryosphere, and atmospheric. And then for this one, we have physical equations, chemical equations, ecological equations, that then we can have to describe this. We need these supercomputers to actually simulate them as we need them. And we have made it more sophisticated with more computing and the resolution, so now we can provide societies regionalized ones. Now, speaking of changes of soil, there are two categories of effects mainly. One that is known by all of you, especially of the sort of name of biochemical effect, when you have deforestation rather by burning, you freeze it decomposes and it emits CO2. So at any rate, deforestation affects, alters this carbon cycle.
And other chemical cycles affect the different chemical composition in the atmosphere, on top of more deforestation, more CO2, more global warming. I think that's clear enough for us to understand, but there are also other effects which we can understand as biophysical effects, which have been included or been reviewed in this report recently, and they have to deal with the fact that whenever the physical characteristics of the surface are altered, for example, liquidation, where you have a dark green and then you pass it to the bright yellow, absorption, different solar absorption. So this affects the surface and the temperature as such as well. And it also affects the capacity of the soil to evaporate and to respirate. So that has consequences on the temperature, but also on the water cycle. So these alterations are more complex to learn and to consider for these models, but we are going to look at some models in this presentation, and I'm going to focus on these effects. To see how the report is going to talk about it. So what does the IPCC, the report of 2013 in regard to the impacts that deforestation may have, the impact that may have on the climate? So essentially we have this figure here. Visually, it's what we have for climate impact, so we can start looking at them. There are 6 models. So in the first one, they were given models, a scenario for change of the use of soils, which corresponds to what we are currently living in, and a function of the fraction of crops and pastures. So here we have the orange areas in the tropics, which means that there is an increase of crops and pastures, and there is tropical deforestation. So what is the impact of these scenarios for each of the models regarding temperature? That is the second and the fourth. Everything that is in gray shows that the change made by the model is not significant, and everything is almost agree. So the messages that are being shown in these figures is that either the models or the IPCC are not able to model the impacts of deforestation on climate, or there aren't effects. So there were a lot of issues in the scientific community to refine, to sort of clarify, keeping other elements in mind, which go more over than just the average temperature, average worldwide temperature. So we're moving forward with regional evaluations that maybe don't have anything to do with the temperature, but on a regional level are felt for the populations. So to understand all of the results that I'm going to mention and present here, the biophysical issues of deforestation, we have to keep in mind that there are 3 fundamental aspects for our forests. They are dark, which shows how much solar radiation they can receive or absorb. They are transparent, means that they breathe through the leaves and they can exchange better. They exchange energy better than other plants. And looking at each of these, when we deforest, we change each of these different properties, which is why the land changes and the water cycle changes. So we're going to look at a model, an ideal model, the deforestation with this article where essentially the whole world was deforested, everything replacing forests for plains. So in the function of the regions here, we can see the tropics, and towards the right we can see the regions that are drier. So we can see that when there's deforestation in the tropics, there's an increase in temperature. But when we look to the more borealis temperatures, there is cooling. And we can see this with the second panel down here, which, if you will, distinguishes the contribution of the different biophysical phenomena. Essentially, it is due to the blue bulb, which is the albedo bar, which is reflected. So what happens in the borealis regions when there is deforestation? The albedo is increased. So we move from a dark green to a region where the snow is dispersed in the region, so it is now radiation or radiating essentially. So now what is happening in the tropics? So this effect isn't being felt as much. Predominantly, you have a combination of evaporative efficiency. So essentially, the evapotranspiration is increased, so there is an increase in temperature, and that is the phenomenon which we see primarily. These effects are very complex and they depend on the regions, and they are added onto the effects we see by carbon. Obviously, when we deforest, we have to have the gross, we have to see the concentration of carbon dioxide in the atmosphere. So this report as such, it goes further than 2013, looking at the regional local impacts, the impact on the hydraulic cycle, and emissions that don't essentially have to deal with CO2, and impacts on extreme events that are much more harmful to human societies. So up next we're going to look at some examples which illustrate these events. In this research here, for the first point, which has to deal with the regional hydrocycle, we have to see how deforestation affects on a regional level the hydrocycle. So we're looking at the regions that have the most, the heaviest hydrocycles, and there's a monsoon season, and that affects more than 2/3 of the world. And in these monsoon times, there is very important impact where there are not enough food, so the monsoon essentially results due to the seasonal contrast in the heating of the land and the oceans. So in the months of the summer, the earth gets very hot, generate an area of low pressure, and as such, the air masses that come from the ocean are sort of sucked in towards the continent, and what they discharge is the monsoon. So how do these changes in soil coverage, how can they affect this hydrocycle, and by how much? So we've done this with many different models, and we're going to look at in detail. We're going to look at 8 different regions where you have monsoons, and we are seeing how these monsoon rains are reduced, and those are the red patterns. In each of the regions, more or less, there is a reduction of the monsoon rains when deforestation is implemented in the IPCC models. Of how much exactly, you ask? Well, in this figure, this chart, in we have the 8 different areas, 8 different monsoon areas. The gray is the change in the percentage of the monsoon rain intensity after deforestation, and we can see that these gray bars are all downwards, roughly 1 to 2%. This means that current deforestation, or if we continued at the rate that we're, reduces monsoon rains by 1 to 2%. And you can say, okay, well, that's not too much, but it has a lot of different impacts, a lot of different economic impacts and the like. But we have to compare them with other factors. And matter of fact, global warming is going to increase the temperature of the rain. The temperature of the air, I apologize. In the air, the hotter it is, the more water it can store. So with global warming, the hydrocycle is going to become more intense, specifically in the monsoon areas. But when we integrate the deforestation model these projection models are reduced by 30%, and even more, up to 50% in regions such as northern Africa. So what this is to say is that the deforestation component, which can be witnessed in models up to 2010, have a higher impact on everything that has to do with hydraulic evaluation, and that has a lot of impact for meteorological systems that have to integrate these dynamics as well. Another effect that go more than the average global temperature. Deforestation also affects the carbon stocks, which the biosphere absorbing before, but here we have two variables. The density of the foliage, essentially how many leaves are on a worldwide scale, and the total carbon that is stored in our ecosystems. The black bar shows the net impact that deforestation has, not only of cutting, but also of keeping in mind the emissions that deforestation has on the carbon cycle. And we can also see that there is 20 to 30%. So what does this mean? That when we implement deforestation in the climate models, there's a reduction first carbon storage in the biosphere. Matter of fact, the biosphere in reality absorbs 28% of our human emissions for carbon dioxide. What this number tells us is that with deforestation, this aid is going to be reduced roughly by 30%. And regionally and locally, we can also revert in all of these regions, for example, in the red and the blue. This is where there is a reversion due to deforestation. So what does this mean? That the biosphere is changing from being a receiver of carbon to be a source of carbon. So now it is not a source of help, but it is another harmful source for us. And this is when deforestation is integrated. This happens in 20% of the tropical continental areas, especially in the borders of the Amazons, which we are starting to see deforested, and in the African forests and rainforests. So now we have the climatic extremes that go over the average. Here we have the same type of figure. We see that for average precipitation there is -8%. That means that deforestation contributed to reducing the prediction of global rains by 8%. That is average. But when we look at more extreme precipitation, for example, the R10 millimeters, which is the beginning of rains that have more than 10 millimeters on a daily basis, the impact is almost 3 times worse. So this goes to say that when we say, okay, 0.1 millimeters for other indexes that are related with flooding, as a matter of fact, the impact will obviously be much greater. So we have to take the average temperature, the average global warming, that will be seen as the effect of deforestation. If we look at the Paris Accord and we look by forests, there are 6 occurrences, or 5. They are always tied into the carbon stock. We don't keep in mind the biophysical effects that I was mentioning. What we see, and this is a chart that I created for this report. we can see apart from tropical deforestation, the effects tend to cool down the carbon emissions that have global warming as consequence. So deforestation of these different zones, global, boreal, etc., historical use of lands, all have effects. And recent literature state that the models are not consensual on the net impact of deforestation for global temperature. But in the current models, there is uncertainty, and there are also challenges, scientific studies, challenges, because to understand the effects of deforestation, there are phenomena that are compensated. There's triple compensation. We've seen that regional compensation, deforestation, tropical deforestation versus boreal deforestation, and as far as the mechanisms when we deforest in general, the albedo is increased, which cools down, but you also reduce evapotranspiration, which heats up, and the biophysical effects counteract the biochemical effects. So there's sort of a triple compensation in the uncertainty. Because although the models show things good, the change and the impact of all of these, when we add them up, the models do not coincide. So I wanted to finish this up, that way we can see if we maybe are not underestimating the effects of deforestation on the global temperature, and I'm not going to go into detail with all of these different phenomena that are not being kept in mind adequately. In the models, but I'm going to illustrate some of them. So if we can see here, for example, the extreme scenario of the IPCC, for those of you that know 8.5, which we would arrive at 4 degrees at the end of the century if we continue down this path. It includes the scenario of the change of the use of land, but also reduction of the use of deforestation rates throughout the time. It is an extreme as far as deforestation. So if we would have a scenario that is a business as usual scenario, it would complicate the emissions. That is an article that AMS had in Nature Sciences, and it looks not only at the change of the land, but also if we're farming, if we're logging, if there is a rotating crop there, etc., that is not properly integrated in the land system models currently. And matter of factly, when we look at these phenomena, one by one we can see the different effects. If we were to integrate all of these different phenomena, the CO2 emissions could be doubled due to the change of soils. And secondly, no model of the recent IPCC report has a nitrogen and phosphorus cycle. And matter of factly, these nutrients limit the taking of carbon dioxide by the biosphere. So if we look at it, if we look at a model that only has the carbon cycle in the future, it seems that the capacity of the biosphere to hold on to this is going to help us when we implement the limitations by nitrogen or phosphorus. Well, it is completely opposite. The biosphere is not going to help us. In matter of factly, it is going to be another source of carbon. Third example, and we were talking about that with the Amazons. The observations show that the efficiency that the Amazons have to store carbon is being reduced in the recent decades. Now it isn't the very efficient carbon provider that it was before. You can see in the little red arrows in the majority of the areas where there's a reduction in the efficiency. But if we see here, even in 2050, we have all of the models, how we would be able to model and show the capacity for carbon storage in the Amazons. None of these have a reduction, only minimally. So the models are very optimistic, essentially, when compared to the observation. So they could be underestimating the amount of tropical trees due to very hot days or just droughts in the region. But nonetheless, if we look at these one by one, each of these different processes which are not well incorporated in this system, they may be participating to adding on to more global warming at this point in time. So conclusions on a scientific level, we see that the biophysical effects have the tendency of cooling the climate. They are opposed to the biochemical effects which heat the planet, and the net effects are still in discussion. But what is truth is that the IPCC models are able of simulating climatic tendencies, sometimes a bit conservative in regards to deforestation on the different cycles and the carbon cycles. Many of the effects of deforestation are not kept in mind, and they may get worse. And also to look at the regional effects, erosion, the ecosystem effects, that way we can give the population the best and most adequate information as possible. So thank you all very much.